first surprise for the Nazis on the American Army front. The rocket-firing Sherman tank is shown for the first time. Shooting 60 4.5-inch rockets, a single tank matches the firing power of 15 batteries of 105mm howitzers. From the rocket tubes mounted on the turret of the tank, the rockets can be shot singly, in groups of 6, or all 60 in a continuous stream. More mobile than any other rocket-firing device, the Sherman rocket tank can both defend itself and lay down a withering barrage.
T-73 demolition rocket launcher mounted on an M4 medium tank developed for the Janet board. Its purpose is to breach anti-tank obstacles and to neutralize or destroy enemy emplacements that might otherwise have to be blasted by hand-placed charges. The front and sides are armored against 20mm fire, and it can be jettisoned if necessary. The launcher carries 10 7.2-inch rockets, which can be demolition, incendiary, or smoke. But the main use is demolition. Now, let's start from scratch. The T-73 kit comes in 2 crates. The launcher's in one, and in the second, the support assembly, 2 brackets, and interior controls. The brackets must be mounted first. To get them in exactly the right place so that the gun sight can be used to aim the launcher, the tank maintenance crew marks off certain reference points. First, with the tank level, a plumb bob is dropped into the turret. The plumb line is parallel to the tank's vertical axis. Then, with the line as a reference, the position of the vertical axis is marked on the outside, in this case about a foot from the line. Next, the plumb line is spotted so that it splits the gun barrel in half. The line is carried back and over the turret. A mark is made which determines the center of the turret. The brackets will be mounted an equal distance on either side of this center. Now, as a temporary measure, a wooden jig is placed on the turret. It holds the support frame in the right position until the brackets for the frame are welded in place. Before the support frame is picked up by a tank retriever, the center section of its armor plate is removed so the frame will fit on the wooden jig. The position of the support frame is checked by measuring from its center to the vertical axis of the turret, which was the first reference point marked on the tank. To be sure the arms of the support frame are equidistant from the turret center, the men measure the distance between the horizontal center line of the turret and each arm of the support frame. They check to make sure that the frame is at right angles to the turret. Because no 2 turrets are identical, the brackets must be cut and fitted for each tank. To do this, cardboard templates are cut to match each side of the bracket. The cardboard templates are then put into position against the turret in the place where the actual brackets are to go. The templates are marked and then trimmed to fit the exact contour of the turret. Of course, this is done for the top and bottom templates of both brackets. To get an even more accurate fit, the outline of the trimmed template is transferred to sheet metal. Actually, either cardboard or metal can be used alone, but for the best fit, both steps are advisable. The metal template is checked for fit. The template outlines are then traced on the brackets, each template on the proper side. The brackets are cut to shape by acetylene torch. Now, to help keep the brackets in place until they're welded, wooden blocks are used as supports. With a carpenter's level and a tape, the men make sure the brackets are in the right position. Tack welding is used in case further adjustment is needed. Brackets on both sides are welded the same way. Once the brackets are tack welded in place, the wooden jig is removed and the support frame lowered on the brackets. The jettisoning latches are secured. Here again, it is only fitted for size. When the crew is sure all parts fit perfectly, the support frame will be removed and the brackets welded permanently. While this work is being done, part of the crew installs controls inside the tank.
Experiments conducted on the Florida coast have resulted in several new devices for eliminating beach obstacles. Prominent among these is a weapon employing the rocket principle. Landed from our invasion craft, this is what it looks like. The demolition rocket launcher, designated by the Ordnance Department as the T-40, mounted on an M4 medium tank. Tests begin with the firing of inert rounds from the recommended range of 100 feet to obtain a pattern. A horizontal pattern fired from the new launcher would be effective against land mines and barbed wire. In the actual firing demonstration, Dragon's Teeth will feel the impact of live 7.2-inch T-37 demolition rockets. A sloping granite beach wall. To breach it, and all other obstacles shown, will not require more than the T-40's full load of 20 rockets. Here's a 6 by 8 foot reinforced concrete wall. Also, an obstacle made up of 3 sections of movable element C. The rockets can be fired manually or at 1/2 second intervals using ripple fire. You'll see ripple fire tested against an unreinforced C wall of this type. Japanese stump walls can prove to be mighty stubborn. We'll show you later whether they stand up in the face of rocket fire. A tank tries to negotiate a Japanese log wall, but the pictures clearly reveal it can't climb high enough. Another job for the T-40 rocket launcher. Past combat experiences have proved that a Jap pillbox can often become an almost impregnable little fortress, very dangerous to attacking troops. 10 rockets are fired at the pillbox. The 10 rockets completely destroy one chamber of the Jap pillbox. The damage speaks for itself. Target, the stump wall. Range, 100 feet. The log wall. Dragon's Teeth. Unreinforced seawall. Element C. Six by 8 concrete wall. Granite block wall. For a first test, 9 of the 33-pound rockets are fired against the sloping beach wall, and an attempt will be made by a tank to negotiate the granite blocks. Let's see how it makes out. Nothing doing. More firing is required because the rockets were fired too high. 10 additional rockets do the trick. With all firing completed, the tank may jettison its launcher immediately and continue with its normal combat duties. The launcher itself is damaged from jettisoning, but it may be recovered and reconditioned for further use. Now back to the results of the firing. As explained, the sloping granite block beach wall first received 9 rockets, then 10 more. A total of 19 rockets to provide adequate clearance for safe and rapid passage of tanks. Five rounds were required to create an effective gap in the stump wall. The 6 by 8 foot reinforced concrete wall was breached by 15 rockets. 11 of the rockets were rippled at one time. Element C had 20 rockets fired at it. Only 11 exploded against the steel, but tanks are able to push through with ease. You'll recall that before firing, the Jap log wall could not be hurdled by the tank. Notice how it goes through now. Only 1 rocket was required to create the gap. The T-40 sent 17 rockets at the Dragon's teeth. 14 were effective. For satisfactory breaching of this type of obstacle, it should be attacked from an angle so as to obtain the maximum number of hits. As explained, ripple fire was used against the seawall. 10 rockets were required. We've shown the rocket launcher's performance. Now, the way it's mounted. Driving the tank into a pit initiates a recommended assembly procedure. This makes it more convenient to place a working platform on the tank. The launcher will be attached to the medium tank through 2 arms which are held by brackets. These brackets are welded to the turret. To perform this welding operation, an assembly jig will be put on the tank. The step-by-step operations begin with lowering the gun to 0 elevation with respect to the tank. The gun barrel forms the support for the forward half of the jig, which is placed in the manner shown. The jig is clamped loosely at first. The vertical set screws on both sides are adjusted until the measurements from the 2 side gauge plates and from the front gauge plate to the machine turret surface are equal. This adjustment assures accuracy in aiming the launcher with the 75mm gun sight. Now the side spacing screws are set and the nuts tightened. The bolts on the gun clamps are also tightened. Then the rear portion of the jig can be attached to the front part, already in place. We are ready for the brackets. Because of variation in cast turret surfaces, the brackets must be cut in the field for each individual tank. cardboard templates serve as cutting models, and they are fitted in the proper place for each of the brackets. This is the template for one latch plate. The line for cutting is marked off. The purposes of this film do not require the showing of the actual cutting and welding operations. But here's the finished bracket, accurate as to size and placement. In a like manner, the mounting of the trunnion pin brackets and the jettison roll brackets are achieved. After all 6 brackets have been placed, the jig is removed, and we are ready to hoist the launcher onto the tank. First, the 2 support arms are placed on the launcher trunnion pins and fastened into place. The launcher is next lifted over the tank and will be lowered slightly to the rear of its final position. The arms are swung forward and engaged on the lower trunnion pins in the manner shown. Now we pull the launcher forward, employing a winch to do the job. To relieve the strain, it's helpful to raise the launcher slightly as the cable pulls it forward. With the launcher in forward position, the latch pins can be locked. Finally, the winch cable is removed. The next step is to raise the front end of the launcher until the end crossheads of the equilibrator spring can be engaged and locked. Then the front elevating strut is screwed into the launcher. In order to engage the other end of the strut on a clamp, which has been previously placed on the gun barrel, it is necessary to lower the launcher. Also, the gun must be raised before the strut can be actually affixed. Here, the clamping is completed. The hydraulic and electrical pull-away connection is inserted, starting the operation of placing and testing the controls. At the moment, the hydraulic lines for the jettisoning mechanism are being hooked up. These hydraulic connectors must be leak-proof, but care must be exercised in tightening them so that they're not damaged in any way. Remember, those lines are the heart of the jettisoning system, and getting rid of the launcher after firing is almost as important as the firing itself. A single lever inside the turret closes the doors. 4 or 5 strokes are required. Release of this valve opens the doors. A triple lever controls the jettisoning. While the jettisoning mechanism is checked, clamps hold the launcher in place. Protection for the launcher against caliber 30 small arms fire is provided through armor, placed in vulnerable spots. However, caliber 50 or larger ammunition could penetrate the armor and result in burning and explosion of the rockets in the launcher with damaging results. This is offset somewhat by the tank's ability to fire its rockets in the space of a few seconds. But getting back to the assembly job, we're now greasing the running edges of the rails prior to loading the launcher. The firing box is inside the turret, and electric cables lead through the pull-away connection to these rails. The firing box must be checked before the loading. The safety plug is inserted. The levers move to the fire position, and the rockets can be discharged. Manual firing is achieved as now illustrated. Then the test of the ripple firing mechanism. Before leaving the tank, after firing is completed, the levers must be placed on reset and safe, and the safe the possibility of accidental firing. The launcher is lowered, and it is now necessary to assemble the rockets for loading. Here are the component parts of the 7.2-inch T-37 rocket, containing 33 pounds of composition C2. Combat units receive the rockets with base detonating fuse and booster already in place. Then only these steps are necessary. The shipping plug is removed from the rocket. An adapter is screwed in. As protection against accidental firing of the rocket, a short circuit is provided by a safety clip, which is now being checked for proper placement. The rocket motor is screwed into the adapter and tightened until there are no threads showing. Rockets are greased before loading. And here they go into the launcher. 20 rockets loaded tail first. Note that the safety clip is removed before the rockets are fed into the rails. The non-commissioned officer behind the launcher rails sees that the rockets are seated okay, making proper contact with the tail rings. He must also pull the latch plate to the rear so that the latch will release the rocket. This release is accomplished when the burning propellant exerts a pressure against the latch plate. The non-com also looks for any possible short circuits. Everything checked and double-checked, so there will be no margin of error once the loading is completed and the tank crew takes over. You have seen the performance and assembly of the demolition rocket launcher T-40. It is ready for real action, when and where needed.